Thanks, everybody. It's an honor to get to speak here in front of all of you, and it's exciting because this is a topic that I've been thinking about for a long time, as you'll see, and it's great to have an opportunity to discuss it with an audience to whom perhaps it's relevant. And I think there have been a lot of great talks here today, so I've really enjoyed sitting here and watching this event. When we have a vulnerability, we kind of face a lose-lose situation. So great, you found a bug. What are we going to do with it? Are we gonna disclose it to the vendor? If we do that, we might lose an opportunity to use that vulnerability to collect intelligence or create an effect or something else that we want to do. So there's lost opportunities on the one side. Maybe we decide to retain it so that we can do that stuff, so we can take an offensive action. And if we retain it, right, there's a risk that while we're retaining it, somebody else out there might independently discover it and then use it to launch attacks against our assets or assets we're concerned with, right? And then that means that we missed an opportunity to take a defensive action to prevent those things from happening. And so there's lost opportunities on both sides of this equation. And so that makes this a very difficult decision for us to make. Fortunately, the United States government is very careful about its approach to these kinds of decisions. We have a vulnerability equities process, and there's this blog post out on the White House website from, I think, about a year ago, April of 2014, actually 2 years ago, that talks about this process at a very abstract level. I think that the United States is the only country that's come out publicly and said that they have a process for considering these kinds of things. And there are a few details that are provided in this blog post that kind of explain, in a really general sense, what kind of considerations are included in this decision-making approach. So, what is the vulnerability in? How many people are running the affected systems? What are the consequences if somebody finds this thing? Those are pretty obvious considerations. And also, like, what kind of intelligence are we looking to collect with this? How valuable is it? What is the opportunity for us? Can the vulnerability be patched? I think that's another valuable consideration. So these are all reasonable things to consider, but this is really vague. And so as someone who's not read into this process, I'm glad that there is a process. It makes me feel better that people are thinking about this, but I can't be certain that the right decisions are always being made because I don't have enough information. So one of the things one of the things that strikes me about this process when I read about it is that it seems like you're talking about this interagency, this high-level interagency decision-making process, and that seems to be a pretty strategic thing. But when we're talking about things that are happening in cyber, particularly like in the Army, we're talking about operationalizing things, and we're talking about potentially delegating the ability to do things to a large number of people, right? And so one of the issues that I'm concerned about, or I have been concerned about when we talk about delegating, is the fact that every time you launch an attack which targets a vulnerability, you essentially disclose the vulnerability to the target. And the question is, how does that fact get factored in, which is something that exists at every single moment when you use the vulnerability, get factored into a high-level decision-making process. So so this is true of most security vulnerabilities in software. It's not true of every security vulnerability. Some vulnerabilities suggest an attack methodology like a man-in-the-middle attack, where the target of the attack is not necessarily, none of the details of the vulnerability are revealed to the target of the attack. But most vulnerabilities involve sending some sort of attack payload, like a malicious website or a malformed PDF file or an exploit packet that contain essentially all of the information about the security vulnerability within them. I used to do this for a living. So I used to work for a group of computer security researchers called XForce Research. We were part of a company called Internet Security Systems that was purchased by IBM back in 2006. And we made an intrusion prevention system. And so an IPS system looks at traffic on the wire and tries to detect attacks by inspecting that traffic and looking for malicious payloads. And so often there would be vulnerabilities that were disclosed out there, and our job was to figure out how to write a signature that covered them. So we had to understand how they really worked. When there were exploits out there that were available, that was actually helpful for this process because we could use that exploit to try to figure out more information about the vulnerability that enabled us to write a signature. One of the naive things that intrusion prevention system developers do sometimes is they write signatures for exploits. They just get the exploit that's circulating out there and they write a signature that detects it. The problem with that methodology is that for a given vulnerability, there may be multiple code paths through a piece of software to the actual flaw in that software that vulnerability, or that is the vulnerability, the flaw that the exploit is targeting. And so if a particular exploit that's out there is only going to follow one of those code paths. And so if you write an intrusion prevention signature that detects that exploit, somebody might be able to write a different exploit for the same vulnerability that follows a different code path through the vulnerable software that completely evades the signature that you've developed. And we would see that happen in the wild a lot. You'd see a publicly disclosed vulnerability, exploits would come out, IPS vendors would put signatures out, and then a few days later, new exploits would come out that evaded those signatures, and a lot of people who thought they had protection in place found that they did not. And so our job, what I was doing about 10 years ago was to do research on these vulnerabilities and figure out what all the vectors were so that I understood them all. And if I could start with an exploit, I could set up the vulnerable software in the lab, set up the exploit, and run the vulnerable software in a debugger and figure out exactly where the vulnerability was and reverse all of those different vectors and potentially come up with a bunch of different proof of concepts for different potential ways of exploiting this vulnerability. So the point is that that attack payload has in it all of the information that I need to do all of that analytic work. And furthermore, it's become pretty standard practice for computer security organizations to have instrumentation in their environment that is needed to collect these payloads during an attack. A lot of people these days have full packet capture at their perimeter. And so full packet, if they happen to know that they got attacked and it's within the window of time that they're doing full packet capture for, then they've got that full attack payload within that capture. In addition, sometimes the exploit might be embedded within malware that ends up getting installed on the target machine. So there's lots of different scenarios where the target of the attack may be able to actually recover that information. So if you're at a target of an attack and you recover vulnerability information from a payload, what are you going to do with it? Well, there's a few different things that you might choose to do. Ideally, you pick up the phone and call your software vendor and say, hey, I just got hit with an exploit that targets a vulnerability in your software. You might want to fix that. That's, for everyone involved, the ideal situation, but it's not necessarily what happens. Obviously, if you are a target who also has an offensive capability or desire, you may choose to use that vulnerability in offensive actions. So you might attack back the organization that attacked you. And so that's a kind of a blowback, right? You might also decide to attack other third parties. So that's a kind of collateral damage. And I'll talk about that a little bit more later on. Another thing that you might do is tell everybody on the internet. And it seems funny. So we kind of have rules of thumb that are not very formalized in computer security around, what do you do in a particular situation? And a lot of people think that the right thing to do, if you find a vulnerability that's a zero-day vulnerability that's targeted your network, a lot of people think the right thing to do is to tell everyone on the internet as soon as possible. And that is a rule of thumb that kind of emerged maybe 20 or 30 years ago in the early days of some of this activity on the internet when the world was a lot less complicated than it is today. And so some of these rules of thumb are no longer necessarily very useful. So a colleague of mine, Holly Stewart, who works at Microsoft, worked with me on a paper which we published at Virus Bulletin in 2013. And this paper discusses whether or not the right thing to do when you find a zero-day vulnerability being exploited against you is to tell everyone on the internet. And what we conclude is basically the attackers, a variety of different entities that perform attacks, have the ability to take advantage of new information about a zero-day vulnerability much more rapidly than defenders do in practice. Most defenders have to wait for a patch, and it's going to take a certain amount of time for the vendor to put that together. But attackers don't have to wait for a patch. They can get instrumented and get going very, very rapidly. To give you an example, so this is actually some data from a retrospective research project that Symantec did on vulnerabilities that had been exploited in the wild before they were publicly disclosed. And so you can see the amount of attack activity targeting those vulnerabilities before public disclosure, and then at the date of public disclosure, it's like a step function, and there's a huge increase in the amount of activity that's happening after that point. So clearly, public disclosure of zero-day vulnerabilities drives a lot of attack activity. And in fact, that's exactly what happened in the case of Stuxnet. So Stuxnet included a number of zero-day vulnerabilities within it, and it exploited a wide variety of systems across the internet. One of the people who got this piece of malware on their system handed it off to their antivirus company, which is a standard practice for a lot of IT organizations. So the antivirus company got it. They get lots of malware samples, they do analysis of them, they try to find interesting ones, and they filter them to researchers, and eventually they figured out that this one was really interesting. And it had in it a zero-day vulnerability. At the time, they only knew there was one. Eventually it came out that there were more. But when they found this zero-day vulnerability in this piece of malware, they did what a lot of people think you're supposed to do. They told everyone on the internet. And so you can see this timeline of when this stuff became public around the 15th, 16th of July in 2010. And immediately there was this huge spike in attack activity because the bad guys were out there and they're like, sweet, zero day, let's go. And Microsoft got a patch out on the 29th. If you've worked on vulnerabilities a lot, that's actually a pretty fast turnaround time for patching a vulnerability of this nature. So they were pretty diligent in that case. Some cases for technical reasons and operational reasons take a lot longer than that. But during this 2-week period of time, there was a lot of attack activity that, me and my co-author of this paper figure wouldn't have happened if the AV company had just kept things under wraps. There were a number of different pieces of malware that were taking advantage of this. One of them is called Sality. Sality is a financially motivated malware operation. They're stealing people's credit card numbers and bank credentials and stuff like that. That's the most common infection that people got as a consequence of this thing. So I talked about how this kind of consequence could be considered a sort of collateral damage. And so I want to talk about that a little bit. I want to provide 3 examples of discussions of collateral damage in this context and talk about what they do and do not consider. The first one is a paper from SciCon in 2012 by Finelli and Conti. It's a very good paper, and it talks about a number of things about Stuxnet. And one of the things it does is it attempts to look at Stuxnet from the perspective of the law of armed conflict. And it says that Stuxnet infected a large number of systems on the internet, but the actual destructive effects of Stuxnet were targeted at specific targets. And so under the law of armed conflict, the sort of effects which are considered collateral damage are only effects which actually destroy physical objects or have the potential to harm people. So the effects that Stuxnet had, which meet that set of criteria, were highly targeted. And therefore, Stuxnet did not cause widespread collateral damage. Stuxnet did affect a whole lot of systems, but the sort of effect that they had on those systems does not rise to the level of what the law of armed conflict considers to be collateral damage. So that's an important analytic point, but Finelli and Conti don't consider this subsequent vulnerability disclosure as part of their analysis. Now, at Cyber Talks in September, there was a talk about a proposed exploit collateral effect potential metric. And this is a really interesting talk. I saw the cyber talk, the 20-minute cyber talk. Unfortunately, I have not seen the paper that it's based on. And so there are a couple interesting things about, so they present this framework for analyzing these questions. And it's actually kind of in some ways similar to the framework that I've been thinking about or put together. So I think that's cool. And they also, they quantify everything, which I think is really interesting. I did not do that. So I'd love to see how the math works, but I haven't seen it. But in the talk, they talk a lot about the idea that we can have this mass reproducing malware that goes out and infects a lot of things, but only has a significant effect on specific targets. They don't really, it doesn't seem, based on what I've seen, that they really consider the possibility of vulnerability disclosure in that context. I wrote a paper, it's a law review article for the Journal of Law and Cyber Warfare. I want to be clear, I'm not like an authoritative source for law of armed conflict. I'm not Mike Schmidt. So this is my opinion, and it's subject to discussion. I wrote this paper because I think that the discussion is interesting, and I'm trying to prompt it. Basically, my understanding of law of armed conflict is that collateral damage includes indirect collateral damage. And so the idea that you did something which caused a vulnerability to propagate and other people were able to take it and cause other effects could be an indirect or tertiary consequence of the action that you took. And so potentially that might be considered collateral damage. Now the problem is, the reality is that for something like Stuxnet, the effects that occurred, you're talking about financial fraud, et cetera, they don't rise to the level of what we would consider to be collateral damage under the law of armed conflict. But there's this other issue here where I think that how the law of armed conflict defines damage is probably going to change. So if you imagine what happened at Sony, if North Korea decided to destroy all of the data that Sony has and completely wipe them out, that would be pretty significant. I think we would be kind of upset about that. Under the sort of framework that says that something is not it's not damage unless something is physically harmed or people are potentially injured, that sort of event, no matter how economically catastrophic it is, it wouldn't raise to that bar, right? And so there may be something wrong with the bar, and that's a discussion that goes on in those LOAC circles, and it's evolving. I don't think that there's a clear answer right now about it. But as that answer gets refined, potentially, if a vulnerability was disclosed in the midst of an action in an environment where people are launching significant attacks, it could be used in an attack that actually does rise to the level of what we consider to be collateral damage under the law of armed conflict. That's the point that I'm making in that paper. So these are the three things that I want everyone to take away from this talk. The first is that inadvertent vulnerability disclosure can have significant undesirable consequences. A whole lot of attack activity can happen on the internet as a consequence of this vulnerability getting out, and even if you didn't mean for that to happen. It is a risk every time a vulnerability is exploited in practice. So you can't just sort of take have one meeting with a bunch of high-level executives and decide, okay, this is fine. Every single time you use that vulnerability to launch an attack, you got to think about who am I targeting, what capability do they have to intercept this, what are they going to do if they find it? I'll talk about that in a minute. It affects every single operational use. The third thing is that it could be the consequence of another country's poor planning, right? We're not the only country operating in cyberspace. So we not only have to worry about whether or not our government is making good decisions, we also have to worry about whether every other government in the world is making good decisions. If some other government does something stupid and causes a vulnerability to be disclosed, it could fall into the wrong hands, and a bunch of negative consequences could happen as a result of that. And so I really think this isn't just a discussion for us to think about how we operate. It's a discussion for everybody to think about how everybody operates. So I tried to think through this the picture here and come up with a more detailed set of criteria for analyzing this question, because I think it makes sense for there to be a public dialogue about this question, at least on the risk side. I think it's important that everyone who's dealing with vulnerabilities understands the potential consequences of the actions they're taking correctly. So the first, on the one side, it's like, what is the probability that something bad is going to happen, right? What is the probability that this vulnerability is going to get disclosed? So independent discovery is the basic thing that everyone includes in their analysis of this question. Like, is somebody going to find this bug before we're done with it? How likely is it for them to figure it out, to exploit it? But in addition, you've got to consider, as I mentioned, discovery by a victim. Who am I targeting? How many endpoints am I targeting? And what is the capability of each one of those organizations to collect artifacts of an attack and analyze them and turn over the vulnerability? You got to think that through. In addition, you also have to consider, insider threat. So the larger the group of people within your organization is that has access to this offensive tool, right, the higher the probability that the offensive tool leaks. So if you're trying to operationalize something, you have to consider the fact that that if large numbers of people have access to it, that either inadvertently or intentionally they might lose control of it. So. On the consequences side, the obvious consequence set is, what are the potential population of third-party victims? So, if this vulnerability gets disclosed, who could potentially be impacted by it and in what way? And that's pretty obvious. There's a couple things that are less obvious. As I mentioned, the disposition of potential third-party attackers. So if one of the targets of this attack recovers this vulnerability, what are they going to do? Are they the kind of person who's going to call the vendor and say, please fix it? Or are they the kind of person who's going to launch their own attacks? Or are they the kind of person who's going to go out on the internet? And then we have to ask about the entire universe of potential actors. So you have to think that through. In addition, what is the potential rate of remediation? If we decide that this has gotten out of hand, how quickly can we put the top back on the pot, on the stove, right? Can we, how hard is it to patch this? How hard is it for people to deploy those patches in production? And different technologies have much different rates of vulnerability remediation. I think that's also, it's important to note that there are things that offensive organizations can do to reduce the amount of time that it takes to remediate a vulnerability that they're using. And I don't know if that's something they think about. So if you prepare a nice, comprehensive vulnerability disclosure package for the software vendor, knowing that once you are done with this thing, you're going to send it, and it's all ready to go in advance, if the situation gets out of hand, you can send it across, and it's you don't waste any time preparing it, right? So there are things that you could do, even as an offensive actor, if you know that eventually you're going to want to patch this bug, and you're going to want that bug patched as fast as possible when you make that decision. So I don't know if I've nailed all of the factors that need to be considered here. That's why it's a discussion. That's why it's useful to be able to put these thoughts out to a group like this. But I think, like I said, so if you think about nuclear deterrence, right? We were operating, and we still are to a certain extent, operating in an environment where there's lots of actors out there with these nuclear weapons, and we need to make sure that no one uses them. And so we need to think about our thought processes. What are we doing with nuclear weapons and in what context? But we also have to worry about what other actors are doing. And it's in our interest that other actors make the right decisions with those weapons, that other actors understand what the consequences of their potential actions are correctly, and that they do the right things. And so I think this is also true in cyber. It's not just about what we do, it's about what everyone else does, and we need other people to make the right choices so that they don't do something that causes a disaster. And so that's my talk. Thank you very much for your time, and I can take some questions.
Thanks, Tom. Great info. Hey, there's some discussion going on in the computer law journals about disclosure. Some of what you were talking about with vulnerabilities, but also security breaches, data exfiltrations. And the fact is that, like some of the numbers that I put up, those are estimates that maybe only about 20% of the actual security incidences. So the discussion is, should there be legislation that says public companies and governments must disclose? And there's really two sides of the fence there. One, if we disclose, somebody's going to know we're insecure and we're not going to do that. But the other side is, if we don't disclose, we're never going to figure out some of these hard problems.
Yeah,
so I'd be interested in your
Thank you. It's a great question. I think that, a lot of breach disclosure requirements require that you disclose the fact that you were breached so that your customers or the people who are dependent upon you are aware of the potential effect to them personally. But they don't require that you disclose how, right? And so those are different discussions. There are issues with the how. There's a whole lot of, and it's not just I don't want my operation to be scrutinized because I don't want people to, it's easy, in hindsight to mock somebody for a technical error, but the reality is that these things are hard, as hopefully all of you understand. And so, but it's also, potentially, people are concerned about providing information that could be useful to an adversary about their own operations. However, if you think about it, every time there's a plane crash, there's a very detailed investigation of that, and all of the detail gets published. And if you're somebody who flies, you can pick up even an airplane magazine at the bookstore, and there'll be a section in there with discussion of plane crashes, and you constantly sort of read that stuff so you know what mistakes other people made. And getting that kind of detail, like this discussion of what happened in Ukraine is I thought it was wonderful, because as defenders, we need to understand what happened in a lot of detail so that we can think about how we can improve our operations to defend against those things. So I'm not sure if legislatively requiring everybody to disclose full details is the right answer, but it's an important discussion, and I think that I would like to see more technical detail about how breaches occur being published so that defenders can use that information for good. So thanks for asking that question.
Tom here. John Grimes,
cyberkinetic
weaponry.
There's a bright light behind you.
Right. So. All you see is my silhouette, I guess. But in mid-November of 2014, I was in Walmart's headquarters in Bentonville in their Fusion Center on behalf of the University of Alabama Birmingham Cyber Center. And I could tell the op tempo was very different. And I think this highlights maybe one critique, maybe one aspect of your presentation that maybe you could give some more attention to, and this is the human factor analysis. When there in Walmart in mid-November of 2014, I later learned that they were aware of the Target breach. And so then the questions for Walmart leadership, and if you work for Walmart, you don't work for Target. Was Walmart under any legal, moral, or ethical obligation to notify Target of their breach in case they were not aware? Right. Number two, would Target go public prior to Black Friday, the one day that is so absolutely essential to their bottom line? And then thirdly is that if they do know and they don't go public, is there anything Walmart can legally, morally, and ethically do to gain a competitive advantage with that mistake? Now, this was in no way shaded by the fact that Walmart believed that it was really Target that was responsible for 100 Justice Department lawyers in their basement when I was there because of the reported Foreign Corrupt Practices Act violations of their store campaign in Mexico. But all this brings to light, I think, the fact that the human factor analysis here must be wedded, in the C-suite at least, with the technical analysis. And let me follow on with this and I'll close.
Okay.
And that's the battle damage assessment. Regardless of whether you think Target made the right decisions or the wrong, their CEO, their CFO, their CIO, nearly their entire C-suite were put on the street. Federal indictments were brought against the company, and they shuttered every store they owned in Canada. So for that, I simply make the point that if there would be any constructive critique, is perhaps more focused attention with the social and behavioral scientists on the first, second, third order effects of these types of discoveries of vulnerabilities of an adversary.
That's absolutely right. Every single vulnerability disclosure that I've been involved with, unless the organization has a really well-defined operational process for dealing with them, it turns into a lot of drama like that, where there are people who are worried about what is the right thing to do, or is it going to be embarrassing for our organization to disclose this? Maybe we shouldn't talk about it. And you, in the heat of the moment, you have some very intense discussions as a consequence of that. But that's actually exactly the reason why I think that having a framework that goes out here, which is vetted by a lot of people, which a lot of people agree with, is necessary, so that we can have a discussion about this that is public, that is objective, when everyone's cool, and we can agree to what are the right things that you should do, so that in the heat of the moment, people can refer back to that and they can say, no, this is what it says we should do, and people have vetted out that this is the right thing. And I think that, you've all been in a situation where you're in an organization that has the ability to take an action, and they want to take that action, and it's going to be useful to them to take that action, and you're going to be the guy that sticks his hand up and says, guys, I don't know, I think we should think about this a little bit more. Like nobody likes that guy. Come on, right? So having this vetted out, and this is why I'm talking about, it's not just how our country thinks about this, it's about how every country thinks about this. Even if I have confidence that we've got this sorted out and we're going to do the right thing, I can't have confidence about every country in the world and how they think. And so that's why I think this discussion needs to be dragged out into a public forum where we can set up guidelines and we can say this is what the right rules are. And we know sometimes people aren't going to follow them, but at least they're there, and it's a cooler head that may prevail in those kinds of situations. But thank you. I think that's a perfectly valid observation.
Tom, thank you so much. I mean, this is what Cyber Talks is always about. It's about talking about and sparking conversation about hard to think topics that people have very diverse opinions on. So this is what it's all about. Thank you so much. And because of this, we'd like to bestow upon you the beloved black badge of awesome cyberness.
This is really cool. I found out about these a few months ago from a friend of mine, and I'm like, man, it would be cool to have one. So
there you go.
I'm like, yes,
way to go. You rock.
awesome.
Thank you.
Thank you.